All right, so video number 2. Make sure you know the difference between angle, side angle, and angle, angle, side. First section says name 2 triangles that are congruent by angle, side, angle. If you look at RQS, it's a lovely triangle, but they're giving us angle, side, angle. Good, that's what we need. The next one, TUV, angle, side, angle again. XYZ, which is a great triangle. However, it is not angle, side, angle. It's angle, angle, side. So you would say the triangle SQR is congruent to, and again, the order is important. S has none, Q has 2, R has 1. So if I go in that same order, none, 2, 1, it would be congruent to VUT. If you did a different order, it would be incorrect. If I look at number 2, all right, looks like those 2 triangles have side, angle, side, or angle, side, angle. And once again, DEF is out because it's angle, angle, side. So triangle ABC is congruent to triangle ABC goes 1, 0, 2. So if I follow the same order here, 1, 0, 2, it would be JKL. All right, so the order again has to be important. If I look at number 3, they're all congruent by angle, side, angle because they have angle, side, angle for everything. So if I start with the first one and I go triangle GHI, I'm going right angle, 1 arc, no arcs. I then go to the next one, which is right angle, 1 arc, no. So that would be OQR. All right. And then I would follow the same path, GHI, right angle, not 1, 0, right angle, 1, 0. So OQR, I'm just checking my work. So that would give me right angle, 1, 0 would be MNP. All right, so make sure you take your time and get the right order. You don't want to do all the work and then get it marked wrong because you have the wrong order. All right, now they tell us BD is perpendicular to AC. So that means both of those are going to be right angles. All right. They tell us BD bisects angle ABC. So those 2 angles are going to be congruent. And then finally, BD, right there, is going to be a shared side. So that tells me my congruency statement is going to be angle, side, angle. All right, so BD is perpendicular to AC, BD bisects angle ABC, given. The definition of perpendicular, again, is right angles, not congruent angles. So angle BDA, congruent to angle BDC. All right. Put a comma there because that's a mistake. Are right angles because they never mention congruent. All right. Then we say ADB is congruent to CDB. All right. That is going to be all right angles are congruent. All right. ABD is congruent to CBD. That's these up there. That's definition of angle bisector. Reflexive property of congruency, that's the shared side. So BD is congruent to BD. And then finally triangle ABD, congruent to triangle CBD by angle, side, angle. Next up, all right, KJ is congruent to MN. KJL is congruent to MNL. That is because it is given to you. KLJ, which is this angle, is congruent to MLN, which is that angle. Intersecting lines, vertical angle property. Okay, now, if you just did those, the triangles are congruent. Okay? The triangles are congruent if you just did those by the vertical angle property. I'm sorry. The triangles would be congruent by angle, angle, side. But if we add the third angles, which you're certainly allowed to do, so angle K is congruent to angle M by the third angle theorem, then we can say JKL is congruent to triangle NML by angle, side, angle. So what that is kind of an escape valve that allows you to not have to choose between angle, side, angle, and angle, angle, side. All right? Couple more, then you move on for your day. PT is congruent to RS, And angle PTR is congruent to angle RSP. Never forget your given. You'd be throwing away free points. You can either do them all at once like this one does, or you can do them step by step. We'll go over both ways, and you decide what's best for you. All right, now PQT and RQS. Well, what a surprise, intersecting lines, vertical angle property. All right, and then we would say triangle PQT, congruent to triangle RQS by angle side. Again, if you wanted to, you could include the P and the R and use angle side angle, but that's up to you. Okay? Last proof. BD is the angle bisector of ABC and ADC. All right? Prove triangle ABD is congruent to CBD. All right, so the given BD, the angle bisector of angle ABC and angle ADC, given. All right, the definition of angle bisector, I'm going to give them numbers. So angle 1 is congruent to angle 2. And down here, because it says it bisects both of them, angle 3 is congruent to angle 4. Yes, Cat, I love you too. All right, they then say BAD is congruent to BCD, so that's those angles. Okay, that of course would be third angle theorem. All right, BD is congruent to BD. Well, what a surprise, shared side or reflexive property. All right, so they ask us to prove triangle ABD congruent to triangle CBD, and that's angle side. All right, a couple more things not mentioned in these proofs that are going to show up as we progress. Parallel lines mean AIA, alternate interior angles. All right, alternate interior angles. Okay, MWR is congruent to KRW by alternate interior angles. You don't need to say anything else. All right. All right, we can't say anything about these angles. We'll discuss more on that because they're not on parallel sides. So those are my alternate interior angles. WR is congruent to WR. All right. So therefore, triangle MWR. Okay, MWR goes 1 to 2 to none. So if I follow that same path, 1 to 2 to none, it's KRW. All right. I got two angles on the side. You ask yourself, did the side touch both angles? The answer is no, so it would have to be angle side. Okay? Equilateral and equiangular figures. An example is a square. If we take a square that's equilateral, all right, all the sides are congruent. If we take the angles that are also, because a square is both equilateral and equiangular, those angles are going to be congruent. So if I move it over, I got that. It's going to be hard to see because that one's black, but I got that one too. Therefore, the two triangles are congruent by side angle side. So equilateral and equiangular figures, remember those phrases. All right. Last one's a circle, okay? Assuming it's circle O, the center. All these segments are congruent. Okay, all those segments are congruent. And then we have these angles labeled as congruent in the middle. So we can say triangle ODC congruent to triangle OBA by side angle side. When you mention those are congruent, all right, you can go about it a couple of ways. Number one, definition of circle. All right, I'm fine with that. Or you can say all radii are congruent, whatever you're more comfortable with. All right, and the order's not going to matter. These triangles are isosceles, so if I messed it up, so if instead of ODC I went OCD, I'd be okay because we still have the one tick mark. All right, so they're the same tick mark, so they're the one kind that are reversible. All right, you want to say goodnight, Roxy? No? All right, so I'll say goodnight for you. Yeah. All right. Enjoy, guys. Be good. Stay safe.